Well, good morning, good afternoon, good evening, good night. I'm not sure what time zone you're in, but I'm in the morning time zone, so I'm going to say good morning. Welcome back to my stream. We're going to be doing day 24. Let me transition over here. Yep. So day 24, and if there's time, I'm going to get to day 25, but let's see what day 24 has in store for us. Yesterday we did day 23, and we I kind of cheated in the fact that I created two separate. Oh, where am I? Yeah. If we look in our source directory, I created two separate solutions, one for part A and one for part B, or one for part 1 and one for part 2, depending on how you name them. So what we're going to do, and we'll refactor those, but not right now, because I'm anxious to get the actual days completed, and then we can figure out how to refactor. I think the day 23 solution. Hi, Smab. Good to see you again. The day 23 solution is more general, and I think if we can just make it vex instead of hard code the array size, we might be able to clean that up. But that's for later. Right now, what we're going to do is add day 24 here. Throw day 24 on this list. And then increment our hack here so that we can run day 24. And mcdir source day 24. Edit source day 24 mod rs. And see if we can get our stuff up and running. Oh, comma. Should be a comma there. Okay. And run. Oh, that's right. I did clean yesterday. Just make sure this works. And what did I break? Oh, that's not used. Okay, that's fair. We'll clean that up too when we do a refactor. Okay, day 24 worked. So I think we're ready. Oops. There it is. I don't know why it was scrolled off the top. Let's see what this is. Day 24, arithmetic logic unit. Magic smoke starts leaking from the submarine's arithmetic logic unit. Without the ability to perform basic arithmetic and logic functions, the submarine can't produce cool patterns with its Christmas lights. Okay, how's that important to finding the sleigh keys? It also can't navigate or run the oxygen system. Okay, that's probably more important. Don't worry though. You probably have enough oxygen left to give you enough time to build a new ALU. The ALU is a 4-dimensional processing unit. It has integer variables w, x, y, and z. These variables all start with the value 0. The ALU also supports 6 instructions. Input, read an input value, add a value of A to value of B and store the result in A. Okay. Multiply, divide, truncate the result to an integer. All right. Round the value towards 0. Okay, so if it's negative, okay. Mod, divide the value by b, also called modulo operation. Right, that's a remainder. And then EQL is if they're equal, then store 1 in A, otherwise store 0. Smab says day 24 is another one I solved by hand, but I have an almost solution. Just one more thing for it to work out. Okay. I'm gonna try it by software instead of by hand. In all these instructions, A and B are placeholders. A will always be the variable where the result of the operation is stored, while B can either be a variable or a number. Oh, okay. So that's going to make the parsing interesting. Numbers can be positive or negative, will always be integers. Gotcha. ALU has no jump instructions. In ALU program, every instruction is run exactly once in a row. Okay, so that simplifies things, right? Program halts after the last instruction is finished executing. Program authors should be especially cautious attempting to execute a div with b is 0 or attempting to execute mod with a is less than 0 or b is less than or equal to 0 will cause the program to crash and might even damage the ALU. Oh, okay. So a is less than, so we're not going to do mod of negative numbers. That makes things easier. And I assume that the player input is not going to have any negative divide by zeros or mod by zeros. For example, here's an ALU program which takes an input number and negates it and stores it in X. Okay. Here's an ALU program which takes two input numbers, and that's it, Z to 1 if the second input number is 3 times larger than the first input number, or set Z to 0 otherwise. So input Z, input X, multiplies Z by 3, and then check to see if X and Z are equal. Here's an ALU program which takes a non-negative integer as input, converts it to binary, and stores the lowest ones bit in Z. The second lowest 2's bit in Y, third lowest 4's. Oh, very interesting. Oh, okay, yeah, it's just doing successive divisions and mods. Okay. Once you've built a replacement ALU, you can install it into the submarine, which will immediately resume what it's been doing when the ALU failed, validating the submarine's model number. Validating the submarine's model number. To do this, ALU will run the model number automatic detector program, monad, your puzzle input. This is probably a Haskell joke in there somewhere. Submarine model numbers are always 14-digit numbers consisting only of digits 1 through 9. Digit 0 cannot appear in the model number. Okay. When monad checks the hypothetical 14-digit model number, it uses 14 separate imp instructions, each expecting a single digit of the model number. Okay, so then it's 1, then 3, then 5, then 7. Okay, I think I understand that. When operating monad, each input instruction should only ever be given an integer value of 1 through 9. Okay. Then after monad is finished running all of its instructions, it will indicate the model number is valid by leaving a 0 in Z. However, if the model number is invalid, it will leave some other non-zero value in Z. All right. So I'm guessing it's going to run some sort of a calculation and eventually come out the end and yeah. Monad imposes additional mysterious restrictions on model numbers. And legend says the last copy of the monad documentation was eaten by a tanuki. That's some Japanese thing, right? Yeah. Japanese raccoon dog. Okay. You'll need to figure out what monad does some other way. To enable as many submarine features as possible, find the largest valid 14-digit model number that contains no 0 digits. What's the largest model number accepted by monad? Begin, get your puzzle input. So what does this look like? Okay. That's exciting. And yeah, I can see negative numbers in there. Okay. Well, let's save that. Okay, so let's just put together a few little things here, and then we'll create, let's see, an instruction enum, maybe, and then we can create an ALU using those instructions. So we can just do an enum instruction. Do I want to spell that out? No, I don't. That's too much typing. So we have input, which is going to take a register, and there's only 4 registers, but maybe we're going to use an index into an array in our ALU. We'll do an add, which is going to take a variable. Oh, it could take 2 variables, which will be 2 uSizes, or it'll take num, which will be a uSize, and this can go negative, so we'll do I64, and then let's copy paste. We have mul, div, mod, and EQL. Div, mod, and EQL. Okay, so if we have all of these instructions, and then we can just create an ALU, which is going to take instructions, which is a vector of inst, and then the registers, which is just going to be I64.4, And is that it? Oh, we have the input. We have the input. So let's just create a vec of I64 for the input. They're all single digit, but eventually we want to be able to put them in things, I'm guessing. We're going to be putting these inputs into registers, right? So if we say input W here, for example, we're going to put it in here. Okay. That seems like it would check, and it does. How do we run this now? Do we want to just create that, or do we want to try to parse the input? Let's take a look at the input again. Day 24. Oh, I didn't move it into place yet. Downloads, inputs, day 24 into inputs. All right. Yeah, so I think we can just use a regular expression to parse this. Well, first what we can do is let's pull in our code. Use create utils read file, and we can just say let data equals read file input day 24, and then we can say for dn data let instructions, and let's say the rest equals d.split once on space, and now we have an instruction. If it's inp, we're going to do some sort of inp thing. Trying to think, because the rest of these kind of have the same thing. I don't want to have to write duplicate code here, which does all sorts of... Okay, let's take a look at what a good regular expression would be, and I do have some other examples here. Let's pull up day 22. All right, I remember that one. Regex. There we are. So we just need two different regular expressions to match a variable followed by a number and a variable followed by a variable. So we'll call it a var num is regex new, and it's going to be var followed by a space. Oh, that's going to be a letter, right? So it's just going to be a single character followed by a space, and then it's going to be num, and it's going to be an optional minus sign, and then any number of digits. Okay, that's one, and then the other one is going to be var, which is just going to be var1, var2, and this will just be a dot. Okay, so one of these two will match. What's the easiest way to let's close that window. We know that this is just going to be a var. Oh, we need to translate the variable to an index, right? Because that's what I'm storing in the instruction, right? It's just the index. Okay, so oops. What's a good way to do this? What I'm trying to think of is here for input, and then we have add, and then I want to match which one, figure out which one matches, and then set the correct one here. I don't know if there's an easy way to do this. Let's just go through one and see how it looks. Let's do add, and this is the rest. We're going to take a look at rest. Oh, I should take a look again at my capture code. Oops. How did I do it? So I just do a captures unwrap. Let caps equals var num captures cube. And it's going to be if let sum, not cube, what am I doing? Rest. So if that matches on var num, then we want to, we're creating a vector, I don't know, what do you want to call it? Vec new. We're just creating a vector of things. We now need to translate the character that we got out of, I guess we could call it variable, is caps of var, and that's just going to be a single character dot chars dot nth 0 unwrap as u8 minus w, and the whole thing as u size. This will be the index into, yeah, and then let num equal caps of num parse unwrap, and we'll just put the type in here as I64, and this is going to be u size. Well, we already know it's u size, I'll put it there anyway. And then if that's true, then we'll just say vec push of add num vn. Wow, this is sloppy code. This should oops. Let's see if this checks. Oh, right, I'm not importing regex. Use regex, I think. Yeah. Inst like that. Oh, unwrap. Is this not able to be done this way? I'm looking here at the error here. It says no method named captures for enum. Oh, I have to unwrap these guys, right? And then parse gets a call, and then inst. Right. So this pattern is not matched. I'll just say panic invalid instruction inst and comma. Okay, so that checks, but I don't want to have to repeat all of it because I only did the var num, and now we'll have to say else if let sum caps equals var captures rest. And we do this. And I hit F1 again. Okay. And then this will be V1, and this will be V2. Oh, this will be add var. Right? Okay, so but I don't want to repeat all this code for every single instruction. I don't know if there's a way around that. I was hoping by doing it once we could see where the commonality was and then just do it. I guess what we could do is strip these out here. I don't know, because we need to figure out if it's var num versus var. right? Oh, this, okay, this doesn't need to be here. So we can put these two up here. But what we can do here, maybe we can get the captures up here. VN cap, var captures rest. Let VV cap, var cap, captures rest. And then we match on the instruction. That only saves this one thing. Boom. Okay, maybe we can simplify it this way. We'll just have to have two matches. Right, we can do this, and then if the var num works, we'll put these here. And then we'll just say match. If if inst is equal to inp, then we're going to just grab the value from rest. So we're going to say let v equals, because input is always into a variable. Yeah. Okay. So v is equal to this mess. Rest chars nth 0 unwrap as u8 minus w as u size. And then we'll just say, wow, okay, it actually found rest. Semicolon, and then vec push inp of v. Oh, inst imp v. Continue. All right, and now we'll do this. So we could ignore the input one and we'll just do the rest of them. So match instruction, and we'll have add, and this is going to be the vec push inst add num bn. Right, and we'll just do the same thing. I think this is probably the easiest way to do it. EQL. I'm glad you made them all 3 letters, because now it lines up nicely. Div mod and EQL. And then anything else is a panic. Invalid var num instruction. Inst comma. Oops. What did I do wrong? There's an extra. I did a right brace and it formatted it in the wrong spot, so I'm thinking I messed something. Oh, I messed this up. There we go. There, okay. Else, if let sum this, right, and then we'll do the same thing as these two guys. And we'll do the same thing as these guys. But now we're going to change these from nums to var. And then change this to v1. And this will v2. Var. Okay, and this all goes away. So does this check? Oops, I missed a brace. It doesn't like that. Oh, I forgot this, and that's an extra, okay? Oh, I call it VN caps. VN cap here, and then VV cap here. and chars. Okay, so that checks, and we're down to 3 warnings. Thank you, Smab. I sorry I missed your comment there. I just noticed you showed me that I mistyped chars as cares. I don't know how you pronounce that. Cars. All right. So this now should come up with a bunch of instructions and get pushed onto the VEC. We can actually probably print them out and see if they look any good. For V in VEC, println, and I'll have to derive debug so we can see this. V. So let's go back up on top and derive debug. Of course, they don't do anything yet. All right, look at that. Input 0, molnum 1. Let's take a look at this side by side with the then we can go sdiff j, and the inputs 24. Oops. Temp k. So this looks like it all lines up. Right? I see imp zeros. I see actually it looks like it has like a grouping of instructions. I see imp 0 every so often. So that translates to imp w, add num2 to 25, so 0, x, y, so that should be adding y 25. Okay, so I think we're parsing that correctly. Let's try to execute them, right? So we'll just say run. Oh, but we need impl ALU pub. We don't need pub. Oh, we need to create a new one though with the instructions. And let's see, I think all we have to do is say ALU here, and then ALU, we say instructions and zeros, because they all start with 0, and then the input vector is going to be new. Like that. Doesn't like that. Oh, I have to say reg. Is that it? Okay, so now we can create an ALU. Let ALU, I'm going to have to make it modifiable, equals ALU new given our vector of instructions. And does that check? It does. All right, so I should be able to now run this. Oh, I need to give it an input. Let's run this with a specific input, because we're gonna, as far as I can tell, we're gonna give a bunch of different kinds of inputs and then figure out what's going on at the end. So run, and we're gonna give it an input. So we don't need to actually pass it in. We don't need to store it here. We can just pass it in. And it's going to return what? Indicate that the model number is valid by leaving a 0 in Z. Okay, I guess we can just return whatever was in Z at the end. And Z is just, oh, we need self. So self reg 3 is going to be Z. Yes. Okay. So let's just try running it, and I'll give it a vector of how many digits? I think it was 14. Yeah, 14. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'll print that. Oh, okay, that's not the answer though. The answer isn't returning 0. The answer is what went into the vector, right? As a number. Okay. But that's all right. Well, let's at least let it run. We'll figure out how this runs, and then we go. We don't have to worry about jump instructions, which means all we need to do is loop over all the instructions for I in instructions self. Match I. If imp of a variable, which means what we're going to do is say, oh, we want to get these one at a time, right? I guess the easiest way is just keep a counter. Just call it current, and then just say variable v. So self-reg of v equals imp of cur, and cur plus equals 1. And then we have the all the other instructions. So add var is going to be a variable, and we'll say a and b, since that's what's written there. It's going to be self-reg a plus equals b. And then add num, and a in number is going to be self-reg a plus equals number. Huh. Okay. And then mul div mod and EQL. And that should cover everything, right? And then we just need to change these. This is multiplied by, this is divided by, this is mod. And then, oh, this changes. So we're going to say self-reg A is equal to self-reg A equals self. Oh, this is not B. This is self-reg B. Self-reg B. Oops. And it's going to be as I64, and then this is just going to be self-reg A is equal to N as I64. All right, does that check? Does not. Oh. Okay, I'm gonna punt on this. Use inst. Oh, move occurs. Let's do that. Slice indices. Oh, and now all of these have to change. Okay, I can do that. Oops. And then these. And the ends as well. Okay, that checks. And this looks like it would do the right thing. I don't see where a bug might be in this. I was thinking, well, we can run a couple of tests and see what happens. I didn't split out the parser into a separate function, so I can't do the parsing thing, but maybe I can just run a quick test here just to see if we can do stuff. Mod tests. Oops. Like this, and then test ALU. We'll create a input. No, yeah, input of 1. Input of 2. Add var 1 and 2, and then we'll see if that results in something. Run, assert, EQ, ALU, reg. They call it, yeah, just reg is vec of 0. Oh, ALU run, and I have to give it 2 inputs, right? Let's say 5 and 7. Oops. And it should be 0, 12, 7, 0. Let's see if we're close. No implementation for this is equal to that. Oh. So we don't need to vec it. We can just say this. Looks like it passed. Where is it though? Day 24. Yeah, okay, so that worked. The add, so we tested the add instruction. That seems to work. I guess we're able to run this. That's the good news. And we're able to get input. That's the good news. So should we just run this and see what results? If I give it all ones, what's left in the Z register? A very large number. Okay, so the answer to, what was the question again? The largest model number accepted by monad is, so it's not all ones. Let's change it to all 9s and see what changes. Now, obviously, I'm not going to look at these 1 digit at a time, because that would be 10 to the 15. I just want to see what the difference is here. It runs pretty fast because there's no loops or anything. It came up with a different answer. So I think the next thing to do is just let's print out each instruction, and as it's doing it, and we can take a look at what changes are happening. 9 to the 14. You're right. Thank you, Smab. I forgot the 0 is not allowed. So I can just say println or print. Let me do a print of the instruction and then say this results in, and we'll print out the result of the registers after we finish executing the match statement. So I println, and then we'll just print out the registers. Self-reg. Oh, and right, this input is no longer used, so we don't even need that. And right, so we don't need that. Okay, so let's run this. And it did a bunch of stuff. Let's see what it's doing. So input 0, so I can see that the 9 was read incorrectly. Multiply number 1, 0. I wonder if I should just write a display thing so we can print it out using this style so I can read it better. Because 1, let's see, 1 is Y. So we're multiplying WX, X. 1 is X. We multiply X by 0. We add 1, we add Z to X. We mod X by 26. We divide Z by 1. Huh. Really? It says that div Z1? Yeah, div z1. Okay. Add x15 equal x and w. So it's checking to see if x and w are equal. Oh, that's actually interesting. That's the first time we actually look at w. So all of this is hard-coded. Whatever comes out of here isn't going to change no matter what the input is. All right. And then we compare x to 0. We then multiply y by 0. Oh, okay. Actually, this just means set y to 0, right? And then add y to 25. So these instructions together just mean set y to 25. Just like these two instructions here together mean add or set x to z. Okay, let's keep going. We add x to y. We add 1 to y. We multiply we multiply z by y. And then we clear y again. Oh, and then here's the second time we check the input. Right. We're adding 4. That's this line here. And then we grab another input. And now we have 13 in Z after that first input. And then we do it. What are we doing here? Are these all the same instructions? No, because this one had add x14 and this had add x15. So those are slightly that's different. But it looks like, whoops. Hang on. Is this just, oops, in W. Oops, what did I do? It looks like, oh, there's a negative 13, but everything else right here, because here we set x to z, right? And then we were looking before, multiply and then set y to 25, multiply y. Are these all the same sequence of instructions over and over again? But then, okay, this blows up, doesn't it? 363, 9461. This just gets bigger and bigger as we execute the instructions until we get to the end, where we get this huge number. All right. So, okay, let me do this then. Quit out of this, quit out of this, quit out of this. Let me change this, because what I want to do is take a look at the instructions. So I'm going to say copy inputs, put date 24. I think this is what you're supposed to do. Is look at all the instructions and see that they're all the same. If I do this until I get to imp, yeah, look, they all line up. So there must be 14 of these guys, one for each digit. I could line them up better, but we can mostly see that they're all the same. General Lovis says this is like those math problems they give you in school. Well, we're decoding whatever this math problem is trying to do, but we don't know what the end goal is here. I know we want to get z to be 0 at the end, so maybe we want to put in like the smallest number we can. Oh, we did that though. We put in all ones, and it still came up with something big for z. So if we look at this, it doesn't start changing until here. This is interesting. So div z, we either div z by 1 or 26 at this instruction. I'm just going to shift these over so they're all lined up. And this is also interesting because the x's change. Right? Either positive or negative. And then over here I see a ragged end. So let's line those up. And so there's a bunch of different values for y as well. So where do we go from here? I guess we can look for patterns. One pattern I'm noticing right away, though, is that anytime we divide z by 26, we're actually subtracting something from x. And anytime we divide z by 1, we're adding something to x. And then, like I was saying before, the only time we ever look at the input, the first time we look at the input is here, and the second time was out here. Yeah. But x and w can only be equal well. Let me try to decode this. So we say, you know, w equals input. I'll just write it in pseudocode here. And then these two instructions together, multiply x by 0 and add x to z, just mean x equals z. Right? And then mod x by 26, x mod equals 26. And then we either divide z by 1 or 26. 1 or 26. Then we add some value. And then we say, if x is equal to w, then x gets 1. X equals w. All right, because if x is equal to w, x gets 1. If x is not equal to w, x gets 0. And then we're going to check to see, does x equal 0? So now it'll be 1 if it's 0 and 0 if it's 1. So we can simplify that to just say is not equal to 0, not equal to w here. And then I think that covers these two instructions. All right, then we multiply y by 0 and add y 25. So that's the same thing as setting y to 25. Y times equals x. Oh, but x is either 0 or 1. So y is 0 if x is 0. It's not equal to w. Oh, if x equals w. Now I'm going to get this backwards, aren't I? Otherwise, y is 25. And then we add 1 to y. So y is either 1 or 26 at that point. We multiply z by y. So z times equals y. So z either gets multiplied by 26 or left alone if y ends up being 1. We then add y plus equals w, and y plus equals some value, right? Some random value here. We then multiply y times equals x, which again is going to either be left alone if x is not equal to w, otherwise, right, because it'll be, x will be 1 if x is not equal to w, otherwise it'll be cleared. Right, because then x is going to be, I mean, yeah, if x is 0, y gets cleared, and then when we add z to y here as the final instruction, so can we simplify this further? I think the first thing we want to do is try to make x and w equal. That would be, I think that would be the first thing to do. And let's take a look at our output again. What did I call it? Oh, I just ran it, didn't I? So I don't have the output. Cargo run, output 24. Output 24. Okay. So here's the first equal check. We're checking to see if x is equal to w. And it's not. Right, because the input was 9. Oh, no. We're checking to see. So we put 15 in x. And we're checking to see if they're equal. And then the result of the equality is 0 because they're not equal. And then we check to see if it's 1. So we invert that. So it's 1 if they're not equal. Right. And that was what we figured out up here. But we can only do single digits from 0 to 9. So we can't make it equal to 15. There's nothing we can do on that first digit that'll make it equal to 15. In fact, I think maybe that's where the negatives come into play. Is anytime we're adding a negative value to x, we want to ensure that it should be whatever our input is. And that way this I don't know why we want to get it equal, but it seems like the thing to do. It seems like what you want to try. Because why else have the check for equality here, right? So we want to get these equal as often as we can. And it looks like there's 1, 2, 3, 4, 5, 6, 7 different places where we subtract from x, which gives us the opportunity to make it equal. All right, let me save this so we can come back to it, and then I'm gonna put this back as our. Oh, that's not our. Oh, I probably, yeah, it's over here now, and it's as wide as it can be. So let's shrink that. Let's put this on the left, and then put this guy on the right. Okay, now we're back to. Oh, we need to get this 100. So the way if I drag this, so normally iTerm will show you in the title bar what the width of the iTerm is, but when it's zoomed in like this, it won't show you. So I wrote a little stupid little print thing of 100. It prints out 100 equal signs, and then I just line it up like this. That's how I get it equal. All right. So I lost my train of thought now. Right, we're trying to figure out how we can get the x's equal. Date 24 mod. So we can hack the ALU. And we can say that, let's just do this. If A is star A is equal to x. So we're modifying our x component, and we're checking to see if it's equal to the w component. Right, that was the instruction, right? Let me just take a look here again. EQL XW. I'll make this nice and big. Yeah, so if it's 1, 0 on the EQL var, then we want to see, oh wow, it made that one bigger too. That's annoying. Where's the negative one? Oh, maybe we want to check on the add after the result of the add, but we can print it out here. We can say, that's unfortunate that Chrome's trying to be helpful, saying, oh, this website is something you want to zoom in a whole bunch of times, so I'm going to zoom in every single tab that has that website. Thanks, Chrome. I wonder if there's a way to stop that, but I'm not going to look now. So what we want to do is print self W should be this now. And I just want to look at it. So we'll say self reg 0, 1, right? We want to see that it's equal to x. So let's run that. Oops. Oh, that's right. I forgot that it's in the middle of printing. So W should be 15. We can't make it 15. Let's look for the next should. Should be 27. Should be 36. Should be 10. Okay. We can't do 10. So we can't do any of these. I thought we had some negative ones. Oh. Oh. Let's switch this back to all ones, because maybe it's just getting too large. Maybe it's just getting too large. Let's run that again. Okay. W should be 15 and it's a 1. Should be 19. We can't make it a 19. 28. 2. Okay, so that's one we can do. And is that our first negative one? Here's negative 13. Let's see if that was our first negative one. That's a positive one. We can't do anything about that. Is it positive? We can't do anything about that. Yeah. All right, so the first time we were able to subtract a number, we were able to make it 2. So which index? I guess we need to keep track of which index we're on. Well, we already do, right? Because we have that here in this current value. So I wonder if we can have this, instead of just returning what's in Z, we can have it return an option of tuple, which would be a usize, which would be the current value and what value it should be. And then we can just update our array that we pass in with those values. And it should be I64. So then we're going to change this to just return none, meaning we successfully ran the program. And this will be changed to return some tuple, current and self reg 1. Oh, but we only want to do that if we subtracted from X. All right, so we don't want to do this here. We want to do it on add num. So if A is that and N is less than 0, then we want to change, we want to say, okay, we want to return self reg 1 plus N. That's what we want. And it doesn't like that. Oh, right, because I changed that to an option. So, okay. So we'll just say ALU run. Let's get rid of this with a vector, and I would just want to have it print out if let sum result equals this, println r.0 and r.1, and let's see if it comes out with what it should be 2, and which input should be 2. It should be the first value should be the input number, and the second one should be the should be 2. Should be the value we want. What didn't it like? Didn't like the fact that I keep leaving off my exclamation point. Okay. So it says that input 4 should be 2, and does that match here? Yeah, so 0, 1, 2, 3. So it's one past, right? It's one past our input, but that's the first negative one. Okay. Okay. So why don't we, if we do that now, so let my input equals this vector, Then we'll run it with that input. And then we'll just say loop until it's none. Else break. And instead of doing this, what we'll do is we'll just say input of r.0 minus 1 equals r.1, and we'll try again. Oops, println trying with this. I'll debug output, input. Doesn't like that. Really? I moved it on the print line? No, it doesn't like that. Value barred here after move. Let me see if I can. Oh, I can just do this. Stop it. And I think Clippy's going to tell me to do this. Okay, and can I get rid of that? I can. All right. So I'm going to run this on the command line in case it runs forever. In case it's an infinite loop. Oh. Multiply with overflow. Well, that's new. That's new and exciting. First of all, this should be a G. I'm going to turn off my I'm going to turn off my print statements here. And just see if I can, if there's anything other than what we just saw. And it's just, oh. Yeah. It's just that. Oh. Oh, I got to check to see if it's not equal to. And every time I run, I see. The reason it's failing is because every time I run, we need to start at 0 again. Reg 0. Is there an easier way to clear an array than this? There probably is. But I think that's why it was panicking. And I need to say if it's not equal to, right, and self reg 1, oh, the next input. If incur is not equal to self reg 1 plus n, then we want to return. There we go. Let's run that. Oh. Now it's not panicking, but it's not moving past this guy. All right, what are we doing wrong? All right, we'll resume this prints here and see what it says. Looking for this. And less. Looking for 2, right? So looking for 2, and now we got the input. So let's check our inputs. 1, 1, 1, 2. So it got a 2. What does it think it is then? So it's adding the negative 13 to the 15, and it should get a 2. input is, oh, maybe I need to increment it first. I don't know. Let's change this, and then in cur. Debugging is so much fun. Oh, oh come on. Oh, input is 1. So what, maybe my current value is wrong. Because here's the 1, and it should be looking. Oh, yeah, I did -1. So this should have read a 2 in. Oh, this is the first one, which is fine. The second one, where are we looking for it? We did read a 2. Oh, we read the 2 already, so it should be in W. That's what I did wrong. Not imp cur. It should be self reg 0. There we go. So this should give us now. Yeah. Okay. So now we got 7 here. Negative. Oh, we can't do -4. Yeah, we can't do those. Okay. So we have to say, we have to check to make sure that it's in range. N is less than 0, and it's not equal, and it's in range. So let looking for self reg 1 plus star n. If a is 1 and blah 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 blah, and looking is greater than or equal to 1, and looking is equal to 9, and self reg 0 is not equal to looking, then we do that. There. Okay. And let me comment these guys out again. And now it should run, hopefully in here. Okay, so now we have actually valid input. But we're not printing out Z at the end. And this is probably the lowest one. We're looking for the highest valid 14-digit model number. So we should switch these back to 9s. But let's print out Z at the end. Z at the end is LU reg 3. That's probably private. No, it ran. Okay. What's Z at the end? 147. Not quite 0. Right? We're looking for when Z is 0. The model number is valid when leaving is 0 in the variable Z. But I think we're on the right track. I think the only other things we can play with are the other digits. The digits where X is not subtracted. And we should actually start from all 9s, right? And see if the same logic works for all 9s. It does. Okay. You can see it found a 4 for this guy and an 8 for this guy and a 2 for this guy, but Z is still not a good number. Okay, so how do we do this with the other digits? I think we just have to try them. How many are there? There's still a lot, aren't there? Okay, well, what else are you going to do? How do we know? How do we know which ones are the good ones? Right, we're looking for the ones where we're adding a positive value to X. Oh, and this is the only place we do an add X with a number. Okay. So whenever we're adding a positive value to x, we actually have to change. We have to play around with the other. With the other values. And how many are those? There's 1, 2, 3, 4, 5, 6, 7. Okay. That's not too much of a search space, right? What's 9 to the 7? 4 million? 5 million? We can handle that. We can search 5 million pretty quickly, right? Especially given that we now can come up with the right number here. So this will be the input. We're going to have a second loop then, because we're going to have to loop over. Oh, we need to keep track of which indices we can change. Okay, we can do that here. We're going to create inc array, which is going to be a vector of bools, which says whether or not each digit can be incremented here. And then whenever we have an add, this is kind of hacky, but I think this is what we're meant to do, is just hack up our ALU until we have something that works. Whenever we're adding a number to v, if v is equal to 1, so we're adding an x instruction, we'll say push inc push n is greater than or equal to greater than or equal to 0. Does that check? It does. So now we should have an array here. Let's print that out. Oh, I hate when I leave spaces there. Println inc is equal to this. Okay, and if I run this, true, 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 false, true, true. Okay, so let's compare that to try. We have true, 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 false, right? True, true, false, true. Right? And then false, true, false, 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 false. Okay. So this tells us which one of these we're going to just have to try all the combinations on. Oops. Okay. I think we just have to try all the combinations on these guys. So yeah, so I was saying what we do is create a second loop, an inner loop, and we're going to just say let try equals input. Oh, we can't use try. Trial input.clone. Then we'll do this loop. I don't care about z at the end. What I want to print out is the resulting input. Because these are the digits we care about. And what we do is then we'll loop through here. We'll try to get all the right values for the non-entries. And then if this fails, if ALU regs of 3 is not equal to 0, then we're going to go through this vector array and lower, decrease each digit one by one based on the inc array. So let mut I equals 0 while I inc I not inc I plus equals 1. So we're going to skip forward to the first digit we can modify. And then we'll subtract 1. If input of I equals 1, then we have to loop it around back to 9. Input, this is kind of sloppy, isn't it? It's 9, and then we're going to we're going to decrement a different one. Let's do it this way. If it's greater than 1, I'm going to say input of I is minus equals 1, and we're going to continue. There. Otherwise, we're going to set input of I to 9, and we're going to keep looking while I is less than input len. Okay. And so I'm going to indent this, and then I'm going to print out next trial is this, and we'll take a look at what all of this looks like. And this is going to be trial, trial, and trial. All right, so what we do is we modify this input vector, we copy it, we modify it until we have all the x's, all the inputs as good as we can get them. And then if we didn't come up with the answer, we'll decrement our incoming and keep looking. And this is going to generate a lot of output if this even checks, and it doesn't check. Oh, I forgot to put the trial. I guess we don't need to print it out twice, right? We'll just say next trial, like that. Oh, reg. It's just called reg. It doesn't like this. It has to be mutable. There. Okay, so if we run this and pipe it into less, what do we see? An infinite loop. So I'm glad I checked. So we must not be decrementing things correctly. So if ALU reg is not equal to 0, while I forgot to break. I said continue here, and I meant to go here. Next trial. This is what I meant to do. So once we decrement it, we can go back up there and try the next one. Next back, next trial. That's a problem of talking and typing at the same time. You'll type in the wrong one. Okay, so now it's getting it 7654321, and it's coming up with a different pattern. Well, looks like the same pattern. Oh no, it's different. Oh, but it's okay. So we have a problem now. It's not going on to the next, because once we get 321, this should decrement to 8. Okay, and that's not. So let's figure out what's going wrong. If input I is greater than 1, we subtract. Otherwise, we set input to 9. Oh, and then we subtract 1 from I. Oh, add 1 to I, sorry. That's what I missed. Okay, so yeah, there we go. Now it's going 8764321. Okay. I think this is working as intended. Just switching back to 9. There's 5, 4, 3, 2, 1. And then this guy should start decrementing. Yes, that went to 8. Okay, so let's stop printing these out because that's a lot of output. And then see cargo, run, release. See if we get close to something that has a decent runtime. Nope. And I should also check if we go too far. Yeah, we got an infinite loop somewhere. It's not doing what I was hoping it would do. What's probably happening is I is not less than input len. If I is greater than or equal to input len, print len, no value found. So I'm hoping this does not show up. And it just takes a while to run. It is pretty slow. Let's take a look at it over here in this tiny font to see if there's anything I can think of to improve this. Right, there shouldn't be that many. It's still running. Like I said, there's only 4 million. And then times however many attempts we need to do here. Yeah, I think this is right? And while I is less input line, we start at 0. If we're not supposed to increment this one, then we skip it. Or, yeah, decrement, I guess. I called it inc. If input is greater than 1, then we subtract 1, and we go on to the next one. And we saw that all working. Otherwise, we set it to 9 and look for the next value to decrement. It's still running. So yeah, I mean, it should have run out of numbers by now. All right. Let's kill it and take a look here. Maybe I can just print the each try and just look to see maybe there's some pattern I can spot of what we're supposed to be doing. It seems to be working. 6, 5, right? And it's not changing this guy. Maybe I can print that out. Maybe that'll help. So print this and then print out the resulting as successful as we got it. And see. So just to pick one here, we see I have 1, 7, and it changes to 1, 7, and then 4, 8, 2. And you can see here, 6339 changed to 6334, blah, blah, blah. I mean, there are a lot of them, but there aren't that many that it should loop that long. I don't see where the failure is here yet. Let me take a look at printing out here. Say if I is greater than, let's see if there's 14, maybe I is greater than equal to 8. And then like this. We have to do a new line because of this input, and this will just print it out when I is big enough, so we can watch it. We can watch it slowly go down. I guess I don't want the new line then. Okay. Oh, unreachable statement. It's been saying that this whole time. Why is it unreachable statement? Oh, because I'm supposed to break. I wonder if that was the issue. It's just searching the entire space. Is that it? If that's it, I'm gonna be sad. it came up with an input that's very large and very suspicious. So what I'm going to do is I'm going to take this input before I even try it. So this is all in 9s here. I'm going to try it by hand here. Oh, I can't do it this way, right? I need the actual program. So let me do it this way. Let part 1. And then I'm going to run the ALU and then exit. So we'll say let mod ALU equals ALU new vec, because those are the instructions, and then I'm going to say ALU.run ALU run what with part 1, and that fails because there. Okay, and now I want to re-enable these guys because I want to see the run. With just that input. Oh yeah, see it exit. Oh, yeah. It exited because we didn't change any of the other numbers. Okay, that explains that. What I'm doing is I'm printing the input. I should be printing out what the trial is, and we don't have the trial. So we can do it this way and say answer. It ran really fast though. I like that. Oh, I need a semicolon here. Not here, here. I didn't want that. Okay, we have a different number. Should I just try it and see? Or should I do that thing I just did? Which I just deleted all the code to do that too. I should have commented it out. All right. Yeah. Actually, we can just do this, right? Let me hit ALU. And then we're going to just say ALU run with part 1, right? And then just standard process exit 0. We do that all over again. And then I'm going to comment these back in and just take a look at it. I mean, it does end up being 0. Do we want to trust it? Nope, I copied that, unfortunately. Here we go. I should print out the output a little nicer, because now I have to remove the spaces and commas. Uh-huh. Okay. All right, that's the right answer. I'm not sure how you do that by hand, though. I mean, I guess you could try one by one, but that would be painful to do by hand, to do the calculation, unless you have a, like, I simplified the calculation a little bit, but I'm sure this can go much, much simpler. So maybe it is pretty easy to, if you simplify it, then you could just write a little program which runs just your simplified code. But this did the trick. Let's see if we can. I'm going to delete this for real this time. Let's see if we can print out before we look at part 2. Let's get rid of all these things. And I don't need this anymore. Okay. And then we don't want to print the answer like this. We just want to print out for A an answer. Maybe this is the easiest way to do it. Print A and then print line. Okay, cardinal run. Let's see if it comes up with the same answer. Nope. If I hit Control Z too quickly after while the oh shoot. And now I've lost the input. No, it's right there. Okay. Let's just do that and then cargo run. There it is. So 91897399498995. Okay. All right. So this is part 1. I think this is fairly decent. This is kind of ugly here to increment those values, but it does the trick. So get status. We don't want output 24 and we don't want try. So get add inputs and source. Commit -m day 24 part 1. Push that. Oh, yeah, I got to clean this up. All right, so it takes 2 seconds, but I bet you in release mode it goes faster. Yeah, 123 milliseconds. Okay, that's not too bad. I can live with that. All right, let's look at part 2. Oh, down here. As a submarine starts booting up things like the retro encabulator. Retro encabulator? Oh! I remember this video. It's like a whole bunch of different buzzwords, and it's kind of cool. I actually worked at Rockwell at one point in my life. Let me put that here because this is, well, I mean, you can get it from the Advent of Code site, but I'll just put it in chat real quick in case people want to just click on it. This is a pretty funny video. You should check it out. I remember that. You realize that maybe you don't need all the submarine features after all. Okay, what's the smallest model number? What's the smallest model number? Well, I mean, we just do the same thing except the opposite. Right? We can just start at 111111 and work our way up from there. That means duplicating all of this code. Unfortunately. We don't need a new ALU. And instead of starting at 9s, we start at 1s. Like that. This stays the same. We still need to figure out the correct X values, but the Z values are going to change. We're going to start at the end. And we're going to subtract our way to the top. And we're just, I was thinking, okay, how do we ensure that I never goes below 0? Because I is going to be a U size, and we don't want to get below 0. But I think we're going to find an answer. If I ever gets below 0, that means there is no answer. So I don't have to worry about that case. While I is greater than 0, and now we're going to decrement I. And now, while input is less than 9, input plus equals 1, and we try the new trial. Oh, it's going to be next trial 2, because you can't reuse loop labels at the same in the same block. So while I is less than 9, we're going to increment I. Otherwise, we're going to set this to 1, and we're going to decrement I here. And while I is... yeah, this will blow up before we even get there. And then we break trial. Same thing, and then we can just print this out again. Day 24, part 2. It checks. And oh, okay. So there's some more debugging to do. I guess I didn't do all the things right. It should have come up with an answer by now, right? If part 1 comes this quickly, part 2 should come pretty quickly. What did I mess up? So we start I at the end. While I is greater than 0. Oh, now I is greater than 0. Yeah, while I is greater than 0, then we're going to check to see if we can increment this value. And if we can, if we can't, we move back 1. If input is less than 9, then we're going to try to increment it up to 9 and go to the next trial. Otherwise, we set input of I back down to 1, we move I backwards by 1, and then keep going. Okay, yeah, that looks all right. Let's print lin trial again and watch as it goes. Oh, we're going to do a print like this, so we can do this like we did last time. Trial, and then after we're done with this loop, we're going to see what it turned into. Slash Life says morning. Good morning, Slash Life. Thank you for joining. Okay, so and let's just pipe that into less so we can take a look. Oops. I'm not seeing what I expected to see. I expected to see a start and then a full end. It looks like we're getting each individual one. I don't want to see that. I just want to see the end of it. Yeah, that's this. Oh, here. That's what I meant to do. Okay. Yeah. So it's coming up with values. Is it changing anything? Yeah. Oh, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this gets incremented. Yeah, so 3, 1, 9, 1, 9. And 4, 1, 1, 1, 1. That makes sense. Yeah, I mean, it looks like it's doing the right thing. 9. I'm just looking down here just to see. Yeah, and then this goes to 2. Okay. If I is 0, println incremented 0. And I keep forgetting the bang. All right, and I'll comment these guys out. I just want to see if we get that far. Oops, what did I do? I broke something. It's probably on this thing here. Yeah, I forgot the closing brace. There we go. Okay. Let's see if this prints out anything. If we ever increment 0. All right, maybe we're not getting there. Oh, did I say greater than 0? I did. There we go. There we go. I bet you that was the problem. Fingers crossed, please. Oh, okay. All right, we'll give it a shot. That took a long time. It took 6 seconds to run in release mode. Aha! And that's the right answer. Excellent. Okay. So it involved duplicate code, but then switching around the increments and stuff like that. I think we got it. All right, let me get rid of these guys. And that's good enough for me. I normally do Clippy and cargo format, but because I have this dead code here, I got to clean up from the thing and I got to refactor. I'll worry about all that stuff later. And source git commit -m day 24 part 2. Not too bad. Part 2 is a little easier than I thought it would be. All right, let's push that up to the repo. And it should be over here. Okay. /life says, I'm beginning to wonder whether I'm the only person solving this without any writing code for it. No, actually, Smab UK, who was in the chat earlier, also did it by hand. I'm not sure how they did it because I'm not sure how you did it either, /life, because it seems like it's a lot of work to try to figure out. But there was that thing. Actually, I deleted the part where I deleted the text file where we were decoding what the instructions were doing, and I can imagine that the instructions can be vastly simplified, and you can just write a little program just to run it real quick. But yeah, /life, hats off to you for being able to do it by hand. That's not something I could do by hand. And that noise, I don't know if you can hear that noise in the background. There's a generator running. We just lost power at my house, so now we were running off of generator power. Okay, so we have oh, 1 second. I got a knock on my door. Hang on. Okay, sorry, I'm back now. Disassembling and analyzing, do I intend to give that a go? I went as far as I thought I needed to. Let's take a look at the input again. Basically, figuring out that we subtract from X every so often. Yeah, like here. And we need to make sure that W and X are equal at that point. So I think that was all I needed. That was the hint I needed to get this to work and have the code figure it out for me. But I know that you can simplify this a lot more, right? Because you can right now. I had say x equals z mod 26, and then we divide z by 26, and then there's some if then else stuff in here that they use with the multiplication of x by y and stuff like that. That's probably more brain than I have to figure all that out easily. So I'm gonna pass on trying to simplify that even more. Let me look over here, and let me take a look at my commits. Yeah, okay, there we go. Day 24 is part 1 and 2. All right, and day 25 in the past has been pretty straightforward. It's been a relatively easy in comparison to previous days, and it's only one part, because part 2 is solve all the other parts. So we'll see if that's the case. So let's set up for day 25. day 25, day 25, and then change this to a 25. Cargo check. RS and day 25. We're going to run this. Oh, I should fix that. Let's get day 25. So, okay, we got that here. So that's working. Day 25 framework. Source day 24. And we want to change this to not equal to 0. Okay. Oh, no, we don't want to change it to that. Eric Blog says, how's your Christmas been? How's the Advent of Code been? Advent of Code's been a lot of fun. My Christmas was fun. I visited family. How was yours? Hope you had a good time. Hope everybody had a great holiday, whatever you celebrate. And Slash Life is now explaining how this works. Okay, the basic idea behind the code is that they're building a stack in Z. If you satisfy EQLWX, you can unstack if there is a div Z26. If you do not satisfy that, you add to the stack instead. And 7 of the input blocks have the offset on the check so high that it can't be satisfied. So you have 7 forced stacks, which you need to pair up with the according unstacks. Okay. If you analyze it, you get 7 pairs of digits. The input match together in the way such that digit 1 is equal to digit 2 plus some offset. Oh, okay. That makes sense. That makes sense. Yeah. No, if there's time, maybe tomorrow, if there's time, I can take a peek at that. My normal streams without Advent of Code are working on a roguelike. So maybe we'll spend a little time in the morning taking a look at analyzing that and then switch over to the roguelike. So I don't want to do this while I is not equal 0 because we definitely want to be able to decrement. So I'm just going to make this a loop. And I should be able to still cargo run. Oh, not day 24. It's off by 1 now because of my hack yesterday. Yeah, so the warning's gone. And oh, I forgot to run this release. And it takes 6 seconds in release mode. So let's just double check. All right, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000, 6, 1000, 7, 1000. Close. Okay. I was saying my 1000's too fast. All right, I think that's the same answer as before. Is it still up here? Yeah, 511, 211, and ends in 1391. Yep. Okay. So git status, git add source, git commit with 2 M's. Day 24 cleanup.